Section 2.2 involves logic. We're going to talk about a few definitions first so that when we're discussing, everything makes sense. A statement is any sentence that is either true or false. Is often represented by a letter. So I could say, well, here's an example down here. I'll wait on it. Truth value is the concept of whether the statement is true or false. So a statement can have a truth value of false. For instance, here's a statement. It's statement P. It says Raleigh is a city in North Carolina. This statement is true. If I said statement G is Spartanburg is a city in North Carolina, then this statement has a truth value of false. The negation of a statement has opposite meaning as well as an opposite truth value. And it's done by a little twiddle. So when I put a twiddle in front of this P and I come up here to what statement P is, now I know the negation of P is Raleigh is not a city in North Carolina. The truth value of that is false. Compound statements are two or more statements joined. They can be joined by and, or they can be joined by or, and we're going to discuss both of them. So for instance, if I say P is a statement that says Spartanburg is a city in South Carolina, and I say R is Spartanburg is a city in the upstate. So P and R, which the conjunction is represented by this symbol. That means P and R, okay? That would tell me that Spartanburg is a city in South Carolina and Spartanburg is a city in the upstate. So that's P and R. So a compound statement joined by two or more statements with the word and is represented like this. You can always remember that because you can make that into an A. Now, in order for that statement, P and Q, to be true, both P must be true and Q must be true. So a conjunction is true only when both statements are true. The truth value of P and Q is true. Okay? Because both of those statements, this one and this one, are both true. Here's an example. You've got statements P, which is 1 foot is 14 inches, Q, which is September has 30 days, and R, which is a plane that's defined by 3 non-collinear points. I can write compound statements and the truth value for each of these conjunctions. P and Q says 1 foot is 14 inches and September has 30 days. Okay, that is P and Q. The truth value of this is false because this statement is false, this statement is true, and so remember how I said if you have an and between them, they both have to be true for your conjunction to be true. So the truth value here is false. All right, let's do a couple more and we'll keep referring back to this. Okay, we've got R and P. So R is, I got to figure out if it's true or not, a plane is defined by 3 non-collinear points. That is a true statement. That's how we defined it. So if I have R and Q, which is what I have here, I would write, a plane is defined by 3 non-collinear points and September has 30 days. That's true because they're both true. Then if I come down to this one, this is the negation of Q and R. So I'm going to take this statement and I'm going to put a not in it. September does not have 30 days, and a plane is defined by 3 non-collinear points. Now, that saying September does not have 30 days now becomes false. So this one would now be false. The negation of that is false. This one is true. So this statement here is false. Now remember, you're taking the negation of it. So that typically has has the word not or no in it, and it has the opposite truth value as the original most of the time, not always. Okay, so then this one is the negation of P and R. So the negation of this would say 1 foot is not 14 inches, and a plane is defined by 3 non-collinear points. Well, if I'm going to take the negation of this, now all of a sudden it's true. 1 foot is not 14 inches is a true statement. So now I have a true and a true, so this statement is true. A disjunction is a compound statement of 2 or more statements joined by the word, shouldn't be and, should be the word or. Okay, it's represented by a V. So P or Q can be represented as P, V, Q. Okay, now the one thing about this is if either one of them is true, then this conjunction is true, or disjunction. We'll call it a disjunction. Example, we're going to use the following statements to write compound statements for each of the disjunctions. Then we're going to find its truth value. Same thing we just did, but this time they're or statements. So let's figure out whether these are true or false. AB is proper notation for line AB. And that actually is false, because what it's missing is it's missing the line over top of it. Okay, so that would make that a false statement. Centimeters are metric units. That's true. 9 is a prime number. That would be false. 9 is a composite number because 3 times 3 is equal to 9. Remember, prime numbers are numbers that only have 2 factors, one in itself. Okay, so if we're going to do these two, P or Q says AB is proper notation for the line AB, and centimeters are metric units. So this one is false, this one is true, but it has an or between it, so as long as one of them is true, the statement is true. This one says Q or R, so this one says centimeters are metric units, or 9 is a prime number. This one's true, this one's false, so my disjunction is true. Venn diagrams are diagrams with intersecting circles, and they can represent the information that we have. So if I have this, I might have this statement, P are, you've got U.S. state capitals, you've got cities in North Carolina, and the intersection between them is R. So on this diagram, I don't know how to show you both at the same time. Okay, maybe we can do it that way. Okay, it says, statement P, Jerica lives in a U.S. state capital. So she lives within this. Jerica lives in a North Carolina city. So she also lives within this. The intersection between the two is where Jerica lives. Jerica, so P and Q, is this R. Jerica lives in a U.S. state capital and a North Carolina city. which we happen to know is the city Raleigh. So Venn diagrams can be used to answer questions quickly. So here's a Venn diagram of students enrolled in Monique's dance studio for tap, jazz, and ballet. So looking on this diagram, we're going to answer several questions. Okay. Don't know if you'll be able to see both at the same time, but we'll try. Okay, so I want to know how many students are enrolled in all 3 classes. So I'm looking for the intersection where these 3 circles combine, because that's the number of students that are enrolled in jazz, tap, and ballet. See that intersection? That is in the circle with jazz, that's in the circle with tap, and that's in the circle with ballet. So there's 9 students involved in all 3. The next question is, how many students are enrolled in tap or ballet? So tap or ballet, we're going to have 28, which is just tap, plus the 13, plus the 9, plus the 17, now plus the 29, hold on, messed up on my calculator. Okay, so 28 plus 13 plus 9 plus 17 plus 29 plus 25. Now I do not add the 17 and the 9 again. So we get 120 total students are enrolled in tap or ballet. Then the third question is, how many students are enrolled in jazz and ballet but not tap? Okay, so jazz and ballet would be here and here, but I can't count the ones that are in tap. So students that are enrolled in jazz and ballet are 25, but of those 25, 9 of them are enrolled in tap too. So I go 25 minus 9, so I know my answer there is 16. Notice there's an and statement there. So I'm looking for the ones that are in both of these, but not that. So I've got to take that 9 out. So you can see how Venn diagrams can be used to answer easy questions. The other thing in this section is truth tables. And truth tables are a convenient way to organize truth values of statements. You don't have to know what the statements are to do truth tables. So this is a truth table that shows you a negation. So I've got P and I've got the negation of P. So if the statement P is true, the negation of P would be false because it's going to have the opposite value. If the value of P is false, the negation of P would be true. All right, this would show a conjunction. So I've got 2 things rather than just one. So what I'm going to do is I'm going to come up with a pattern to represent everything. So if my pattern says T, T, F, F, you know, when one possibility is that P is true and Q is true, or T is true and Q is false, then if P is false, then Q can either be true or Q can be false. Those are all the different ways that I can have a P and Q and have true or false statements. So I have true, 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 false, false, true, and false, false. There's no other way to do it. This one, notice, is a statement that combines the two. And it has the symbol for and, which means for this statement to be true, both of those have to be true. So that's true. This is false because you see I'm comparing this one, and this is false. This is false, and this is false. So the only way for this conjunction to be true is if both P and Q are true, which is this one. Now this is a disjunction, so this is an or statement. Again, I've got my pattern, true, true, false, false. The pattern just helps me create all the different possibilities for P and Q. Okay, so now I'm looking, if either P or Q is true, this statement is true. So that's true, this is true, this is true. The only one that's false is when P is false and Q is false. So you're going to work on constructing some tables, and I'm eventually going to show, and this is my last thing over here, P and the negation of Q. But what I have to do is I have to come up with columns, very organized columns. I want P, I want Q, I want the negation of Q. So here's my pattern, true, true, false, false, true, false, true, false. That helps me, if I keep a consistent pattern, that helps me figure out if I've covered all the bases. But then to get the negation of Q, I look at this Q column, and it's always going to have the opposite truth value. So if this is true, this is false. If this is false, this is true. If this is true, this is false. If this is false, this is true. Now I'm looking column P and this column, the negation of Q. So I don't need this column anymore. I'm looking at these two columns, and I'm looking for, this is an and statement, so they both have to be true for this statement to be true. This one's got to be false. This one is true because this is true and this is true. This one is false, and this one is false. Okay, now this one's going to show the negation of P or Q. So again, I have P, I have Q. I'm going to have the negation of P, and then I'm going to have the negation of P or Q. So true, true, false, false, true, false, true, false. The negation of P, I'm going to look back at this column, and I'm going to take the opposite truth value, and then I'm going to compare these two. Okay, if either one of them is true, this statement is true because this is an or. So this is false, this is false. Oh, wait a minute, I did that wrong. This is true because either one has to be true. This is true and this is true because it's an or statement. All right, then we can get real complicated here. Now notice this has a P, a Q, and an R. So now all of a sudden I've got more possibilities. These only had 4 different possibilities. This one's going to have 8 because there's 2 possibilities for P, true and false, 2 for Q, true and false, and 2 for R. So I have 2 times 2 times 2, or 8. So P, Q, R. Then I'm going to need the negation of Q. Then I'm going to need what's in the parentheses. So I'm going to need the negation of Q and R. And then I'm going to need this final statement, P or the negation of Q and R. All right, so let's work on this. I'm going to go half of these as true. Half of these are going to be false. And then the next pattern I'm going to do true, true, false, false, true, true, false, false. And then I'm going to go every other one. True, false, true, false, true, false, true, false. And I think if you'll look at that, you'll see that none of those are repeated. You do not have to follow my pattern. You can create your own pattern as long as every possibility is on here. So I've got true, true, true. There's not another one that's true, true, true. I have true, true, false. There's not another one that's like that, and so forth. All right, so now once I've got all the possibilities, I go through. I'm taking the negation of this column, so the opposite truth value. So that's false, that's false, that's true, that's true, that's false, that's false, that's true, that's true. Now I'm looking at these two columns right here. It's an and statement, so they both have to be true for this statement to be true. So this is false, false, this one is true, false, 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 this one is true, and false. Now, notice I've already got the answer for that. So now I'm looking at P, the first column, in an or statement, because that's going to be or. So I'm looking at the first and the last column. If either of those columns is true, then this is true. So this is true, this is true, this is true, this is true, this is false, this is false, this is true, and this is false. See, both of these are false, both of these are false, and both of those are false. Every other true I have, either there's a truth here or there's a truth here. All right, your homework on this is page 72 through 73, 18 through 44 all.